Alright, for this video we're going to be in your workbook and we're going to be on page 134. And it should say activity 2. At the top have a picture of a parachute and a bowling ball on it. So what we're going to do is do more of comparing linear and nonlinear functions, which is kind of what we've been doing lately. So if you look at activity 2, it says each table shows the height in feet of a falling object at t seconds. So the first thing it wants us to do is graph the data in each table, and they have graphs for us there. Decide whether each graph is linear or nonlinear, and then compare the two falling objects. Which one has an increasing speed? Now this part you could probably answer right now. If you think of somebody parachuting down and then a bowling ball falling, which one would have an increasing speed? You can think about that. And then when we're done, you can look back and see if what you thought was right or not. So first of all, let's look at the falling parachute jumper. Okay, so here's our table. And let's see if I can zoom out a little bit here. Okay, what I'm going to do is I'm going to take these 5 points that they've given me in the table and I'm going to graph them. So, first thing, I have the point 0, 300. So at 0 seconds, it was at a height of 300. So what I need to notice here, my seconds go by 1, and it looks like my height goes by 60s, but really every other one. So up here, if I jump another 2 lines, this would be 300 up at the top. So go ahead and label that. So if my first point is at 0, 300, I'm going to have a point right about there. My next point is 1, 285, so over 1, 285 is going to be about right there. 2, 270 is going to be right there on that line. 3, 255 is going to be about right there. And 4, 240 right there. So I can see, I can connect these here with a straight line, kind of. Okay, you get the idea. It's a linear equation, so I'm going to write this off over to the side. Okay, because it was a straight line. But if we were to look up at the table, my time is increasing by 1 second each time. And then the height is decreasing by 15 feet each time. So since that is constant, you're going to have a linear function. Now let's look at the bowling ball. Okay, it looks like the graph is the same. It goes by 60s up and by 1s along the bottom. So let's graph these. At 0 seconds, it was at a height of 300. So right here. So they both started falling from the same height. At 1 second, it was at 284, which is about right there. Over at 2 seconds, it was at 236, which is right there. At 3 seconds, it was at 156. So right here would be 150, so I'm going to come just above that. And at 4 seconds, it was at 44, so that's going to be way down here. So you can tell just looking at this that your line curves. Okay, so the bowling ball would be nonlinear. It's not a straight line, and there is no constant rate of change in the table. Okay, so if we answer the last question that was up at the top about which one would have the increasing speed, well, obviously the bowling ball is picking up speed as it falls. The parachute jumper is falling at the same rate as they fall. The bowling ball is picking up speed, and that's due to gravity. So, kind of down here at the bottom, we're going to answer that third bullet point. So we'll say the bowling ball picked up speed as it fell because of gravity. Okay, whereas that parachute jumper, the parachute serves to kind of slow down that gravity process. So the weight of the bowling ball and gravity pulling it down makes it increase the speed.